Hello, welcome to required practical number 4, in which we're going to investigate the IV characteristics of circuit components. I standing for current and V for potential difference. In this first video, we're going to investigate the IV characteristics of a filament lamp. The equipment that you're going to be using will include 3 cells, and you'll notice that I've got them all next to each other so we can make sure that they are pointing in the same direction. We have an ammeter which will be connected in series, a filament lamp, a variable resistor, and a voltmeter which we will connect in parallel with the filament lamp. So when we connect the circuit, you will see that a current flows, and we're taking a reading already on the ammeter. And when we connect the voltmeter, we are going to make sure that we connect it in parallel with the filament lamp. And in order to do that, we are going to double-decker the leads. You'll notice that I've chosen different colour leads for the voltmeter, because there's quite a lot of leads here and we don't want to get confused. So, there we go. You can see now we've got the filament lamp connected in series with the ammeter, in parallel with the voltmeter, and we've got readings on both the ammeter and the voltmeter. Let's take a quick look at a circuit diagram for this particular setup. So we've got a circuit diagram of the equipment setup. We can see a battery of cells here. Remember, you'll have 3 cells. We have an ammeter connected in series, your filament lamp, your variable resistor, and then your voltmeter connected in parallel. Once you've got your circuit set up, taking readings is really simple. You'll notice that I've got the slider on the variable resistor pushed all the way up to the far end, meaning that the current's going to have to flow through all of these corners of wire here. So we've got the highest resistance possible through the variable resistor. And all we do at this point is we take a potential difference reading and a current reading. So that's 1.07 volts and 0.16 amps. Once you've written down that reading on your trusty results table, you're then going to move the slider to the left. Now what I recommend doing is moving the slider approximately 2 centimetres. Once you've moved the slider 2 centimetres, we'll take a second reading. So we're now at 1.19 volts, 0.17 amps. And we can move the slider again, approximately 2 centimetres. Okay. Take our third reading, so we're now at 1.39 volts and 0.18 amps. Recorded in our results table. And you will keep going until you get the slider all the way along to the opposite end of the variable resistor. Okay, once you have done that, you are then going to change the circuit like this. You will disconnect the cells. I would like you to spin them round and reconnect them. Bring the slider all the way back to the right hand side so your potential difference and current readings are as low as they're going to get. And this time you will notice that on the ammeter and the voltmeter you are getting negative readings. You're going to repeat the experiment, and this time you are going to record the negative readings on the ammeter and the voltmeter. So you can see we're at negative 1.1 volts and negative 0.17 amps. So you can see I've recorded them on my results table as negative numbers. And you just go through the process again. So we're going to move the slider, going to move it approximately 2 centimetres. We've now got a reading of negative 1.2 volts and negative 1.7 amps. And you're going to continue that process once again until the slider is all the way over to the left hand side of the variable resistor. Once you've done that, you're going to plot a graph of potential difference against current and draw a line of best fit that shows the IV characteristics of a filament lamp.